have seen previously, we can have one solution, we can have no solution, or we can have infinitely many solutions. And here we're going to see a couple of examples that should lead us to either a no solution or an infinitely many solutions. So let's get to work on these. We're going to be using substitution in these examples. So here in this, we got 2x minus y equals 8 system, y equals 2x minus 3. And I can easily substitute, in this case, into that first equation, 4y, substitute in 2x minus 3. And so let's do that just real quickly. So I got 2x minus, in parentheses, 2x minus 3 equals 8. And so I need to distribute a negative 1 to what's inside that parentheses, 2x minus 3. And when I do, I've got 2x minus 2x plus 3 equals 8. Well, the 2x and the negative 2x are going to cancel. And it's just going to leave me with 3 equals 8. Well, we should know 3 does not equal 8. And look what also happens. Both of the variables get canceled out right away. And it leaves me with a statement that is not true. And so therefore, I would say that this is no solution. All right, let's look at one more. All right, here I got 4x minus 3y equals 1 and 6y minus 8x equals negative 2. There's a couple of ways I could go about doing this. Really, if I pause to think, I'll come back to pausing to think. Well, let's say I want to get one of these variables isolated so I can substitute, and neither one of them are easily going to occur. But let's take this first equation, 4x minus 3y equals 1. And let's add 3y to both sides. So I got 4x, we're going to isolate the x, equals 3y plus 1. And now we're going to divide everything by 4. So that x equals 3/4 y plus 1/4. And now I'm going to substitute that in 4x into the second equation. So then I would have, and solve for y, so then I'd have 6y minus 8 times 3/4 y plus 1/4 equals negative 2. Well, let's see. 8 times 3/4 y. Well, 4 going to 8, negative 8 2 times. And negative 2 times 3y at that point is negative 6y. And look what's getting ready to happen. My y's are getting ready to cancel. But let's take negative 8 times 1/4. Well, negative 8 times 1/4, negative 8 over 4 is negative 2. And when the positive 6y and the negative 6y cancel, I end up with negative 2 equals negative 2. So similar to what the previous example, where all my variables canceled after substitution, this time I end up with a statement that is true. Negative 2 does equal to negative 2, and so there are infinitely many solutions. Now, there's more than one way to skin a cat on this thing, and I just want to go over that. If I really looked at this equation, I could see that there's a relationship here. There's a ratio 4 to negative 8, 4x to negative 8x. Well, negative 8x is negative 2 times larger than 4x. And negative 3y to 6y, there's also negative 2 times negative 3y would be 6y. And then look here, 1 to negative 2. If I were to go in, if I had gone in, if I'd looked at those relationships and studied those pretty carefully, I could say, you know, what would happen if I multiplied that first equation by -2, the entire equation? And if I did so, I'd have -8x plus 6y equals -2. And I could rearrange that and just say that 6y minus 8x equals -2. And that's the same thing as that second equation. And therefore, it's the same line. And we know if it's the same line, it's consistent and dependent, and there are infinitely many solutions. So either way, whether I use substitution or whether I really just took a little few moments and just looked at those equations and said, you know what happens if I multiply that top equation all by -2? Or I could have multiplied the bottom equation by -1/2. And if I did, I'd end up with 4x minus 3y equals 1. So as normal, there's often more than one way to skin the cat. But the cat's been skinned in this case, and there's infinitely many solutions.